Welcome to your chapter 2, which is your univariate descriptive statistics. Univariate means single case study. The reason we are understanding or getting familiar with the terminology for chapter 2 is because we are focusing on the understanding and appreciating of research. And we cannot do this without knowing the research terminology. So in this case, we are going to talk about types of data, descriptive statistics, measures of central tendency, and standard scores. As you look at the PowerPoint and you will go through it, I am going to switch back and forth because each concept is intertwined or related to one another. The types of data I'm going to touch briefly because they will be repeated or talked about again in your assignment 2 for chapters 3 and 9. What is my types of data? I have different types of data because when you are representing something, suppose you are representing a comparison, a Likert scale, where you fill a survey that says, do you strongly agree, less agree, neutral, disagree, or strongly disagree? That is what is called an ordinal data. Ordinal data is easy to, from the word you can see it says order. So they are in comparison. Class ranks is in comparison. This is what is called ordinal data. The raw score is the score. Raw score is either interval or ratio in which we actually use the data to do statistics on it. That is the data that we actually manipulate. Find out a mean, find out an average, a median, a mode, which will we talk about in just a minute. Nominal data is we are giving a numerical piece of data to a category. For example, we are taking hair color. Brown is 1, black is 2, blonde is 3, white is 4. So we have attached a numerical value for the hair color, but we can't take averages of this. Average means nothing in this case. So that is nominal data. But any nominal data that only has a yes or no issue is called dichotomous. For example, gender. It would be male, female, or we could say is do you have a job or you don't have a job? Or we could say is whether the person passed or failed. So that is called dichotomous data. We'll talk about data more for assignment 2 also. So what are my measures of central tendency? Those are the representative scores of the data. So I can have lots and lots of numbers, but how do I interpret the data? Using these things: mean, median, mode. Mean, it's the average. You add up the items and divide by how many items they are. Median is the middlemost. Mode is the most repeated. I'm going to come back to this slide, but let me go to the next slide. So when you're considering, let's say this is my distribution, and I arrange them in order. So median is the middle number. So 9 is my middle number. So I can say, suppose this was a test that I gave to my class, and I want to see what was the middle, like what was the median in the class, and the median was 9. So I want to make some changes to the test because the scores had a low median. But when I look at the mode, it is 12 because this is repeated 3 times. So that means that there was a big disparity in the class because a lot of students scored 12, even though the median lays in 9. But now median is not really giving me an idea of how was the average performance of the class. So when I look at the average performance, it is 8.39 because I added all the numbers and then divided by how many they were. So what basically it is which one do we use most often? It depends. Which one is the best? It depends as to what information do we need out of that data. Mode, can we have more than one? Yes, we can have more than one, because if instead of just 2 8, if I had 3 8s, then 8 and 12 would have become my mode. But in case we have two modes, it is not a normal distribution. What does a normal distribution look like? I'm going to show you a picture of it and then we will come back to that picture. So this is what a normal distribution looks like. Here is another better picture. This is what a normal distribution looks like. This normal distribution has your mode, median, and mean at the same point. This is your normal distribution. We want our distribution to be normal, but in most cases, the distributions are not normal. They are skewed, and then they also have kurtosis, which we will talk about in just a second. Another way of interpreting the data is to use the degree of dispersion. That means, are the scores very similar to each other? That is homogeneous, or are the scores dissimilar to each other? There is a high variability. So if you look at page 32 of your book, you have group 1 and group 2. So for group 1, what would be the highest score? 103. What is my lowest score? 96. So when I subtract these two, I get a range of 7. Range is the most simplest measure of variability, which gives us the difference between the lowest and the highest score. Think about over here, what would be my group 2 range? If I have to calculate this, what is my highest here? 128. And what is my lowest here? 78. So what would be my range? Another important measure of variability is the interquartile range. Basically, it tells you what is the spread among the middle 50% of the scores. So I am not taking the 225% that are in the end, but the middle 50% of the scores. What is the middle 50% of the scores? So when I talk about this is, let's look at the picture at the next. Box and whisker plot is one of the way we represent the data. That's why it was said a picture is worth 1,000 words on the first title slide. So if you look at box and whisker plot, your 25% is right over here. The last 25% is here. So your Q1 is 25%, Q3 is 75%, and your interquartile range is between Q1 and Q3. So this is the 50% of the scores. So as you can see, median is the 50th percentile, and that is where it is forming. There is also what is we call is the semi-interquartile range, but that is you are taking half of the half. It is not the 50% of it. 50% is the interquartile range. One of the most important measures of variability is the standard deviation. Any set of scores should have a standard deviation. If you look at page number 35, it tells you that standard deviation and variation. Variation is basically the square of standard deviation, and you can see the symbol right over there. Why do we do a square sometimes? Because our standard deviation can be a plus and a minus, and I'll show you that in just a second. So when we do the square, we will always have a positive. That is why sometimes some researchers refer to variance. Standard deviation is calculated from the scores, and it is a much better picture of the score dispersion. So let's look at the slide. This is one of your most important slides for your quiz. If you're looking at this slide, this is a normal distribution. A normal distribution is a bell-shaped curve which has your mean, median, and mode at the same point. So this is your mean, median, and mode. So your mean is, I'm going to move this a little bit so that you guys can. Your mean is 500 and your standard deviation is 100. How do I know the standard deviation is 100? Because it gives me a plus minus of 100. So whenever I have a plus minus of 100, this value after that is your standard deviation. So what would be plus 1? I add 500 plus 100, which gives me 600. So plus 1 standard deviation is 100 above the mean. Your value of mean can be different. It could be 50, it could be 10, it could be 5,000. I'm just using random numbers, 18, 79, and your standard deviation could be any number too, but it generally tends to be smaller. Here I took a larger one just to show you guys with simple calculations. Now, same way, if I want to calculate what would be the standard deviation of minus 2, so what will I do? I will go down to standard deviation, which would be 500 minus 100 minus 100, which is 500 minus 200, and that is 300. Easy. You have a question like this on your quiz. Now, another thing, what is the score at the 50th percentile? Remember, in a normal distribution, then your mean, median, and mode is at the same point. So when you look at 50th percentile is basically where your mean falls in. So that is 500. What is my 84th percentile? So once again, look at the graph. When you look at the plus 1 standard deviation away from the mean, you see it is 34 and mean is at the 50th percentile. So I can do 50th plus 34, which gives me the 84th. So that means it is the value at plus 1 standard deviation, and that is 600. If you do the calculation, you will see that minus 1 to plus 1 is actually 68 percentile, 68% of the sample. So in a normal distribution, 68% above 50% of the sample write either one deviation, one standard deviation above, or one standard deviation below. If I look at minus 2 to plus 2, that means, and calculate, add all of these up, it comes out to be about 95%. So in a normal distribution, if I go minus 2 standard deviation to plus 2 standard deviation, 95% of those scores will lie there. And then minus 3 to plus 3 is 99 percentile. So think about a score that is happening outside of 99 percentile, like between minus 4 standard deviation, minus 3. That is very highly unlikely. This is where the significance comes in. When we talk about it is not by chance that a score would lie over there. So where do the range of scores fall? Within the middle 68% of the sample, which is between minus 1 standard deviation, that is 400, and plus 1 standard deviation, that is 600. So remember this slide, print your PowerPoint so that you have this slide while you're doing your quiz too. The next is the same normal distribution curve. I have the same thing, and I'm going to touch the z-scores and t-scores here, the standard scores, for very briefly. So first, let's talk about standard deviation. You see the symbol of standard deviation. Remember to look up the symbol for your mean. That is another one of your questions, and it is on page 28, because you can have a mean as an m or an x with a bar and a mu. And your mode is m with a subscript of 0 or an o, and then you have a median. So your abbreviations are given there. So when you look at the standard deviation, it gives you how they are distributed around the mean. If it is small, that means the scores are very tight towards the mean. If they are large, if the standard deviation is large, like 100, so then they are spread out. Standard deviation works no matter what is the mean or set of scores. If it is a normal distribution, your standard deviation will work. There are z-scores and t-scores. They have nothing to do with each other. Your z-scores and t-scores are basically a way to standardize the... All right, let's start with slide 10 again. We were talking last about the standard score, the z-score, and the t-score. Basically, the standard scores are used when a researcher wants to know about a certain score in the data set, certain raw score in the data set. So the standard scores are actually how many standard deviation is a particular raw score from the mean. So the only z-scores and t-scores are nearly the same thing. The z-score is basically the mean is fixed to 0, and then the length is set to 1. So basically how far it is, and then the t-score is the original mean and standard deviation are converted to 50 and 10 respectively. The main thing that you want to know about this is the fact that the z-score tells you how much standard deviation is the raw score from above or below the group mean. That is the most important. So if you have, let's say, a z-score of +2 indicates a person is focused 2 standard deviation from the group mean, and a -1.2 indicates that the person is 1.2 standard deviation below the mean. And that's the same thing for your t-scores. Is if I have t-scores, the mean is a 50, right? And standard deviation is a 10. So if I have a t-score of a 70, that means it is 2 standard deviation above the mean. If I have a score of 38, that means go down 10, that is 1 standard deviation, and then 2 more. 38 is 1.2 standard deviation below the group mean. So like we said, all of this works when it is a normal bell distribution, a normal bell-shaped curve. But what happens if it is not a bell-shaped curve? It is not normal. It throws off your standard deviation. On your page 29 and page 29 and 30 are the ones for you to look at. So if you have your outliers, or if you have scores so this is a negatively skewed distribution, which means that mode is the highest value and mean is the lowest value. So your extreme scores are basically towards your left. The skewness value is less than 0 for this. So let me give you an example and explain what do I mean by extreme scores. Suppose you take a test, a statistics test, and most students did very well, but there were very few students that did poorly. So their scores, the extreme scores, will write on the tail on the left hand side, which will make this to be a negatively skewed graph. In this case, the mean is lower because when we factor those extreme low scores with the high scores, they're going to pull down the mean of the class. But because most students have done well on the test, the mode is going to be the highest. You do have questions on your quiz related to this skewness, negative and positive skewness. So if we look at the positive skewness, we could talk about, we make a group of students to go to the camp or something like that, and we have all the students that are like the ages and things like that. When we did, they were all around the same, and we had very few students who were like in older that went to the camp. So in this case, again, your mode is the lowest value because there were more students of younger age than they were of the older age. If I use the test example again, that means more students did poorly, but the mean was pulled towards the right because of the high scores of few students. So that is why this one is called right skewed and this one is called left skewed, which is negatively skewed. On page 30 of your book, it shows you a positive skewed and a negatively skewed graph. What you need to remember about is where are the extreme scores and which value assumes the highest position. Mode assumes the highest position in a negatively skewed one, and mean has the lowest position, while it is the opposite case when we are talking of positive skewed. The peak is not telling you it is the highest. Remember, this is your x-axis, so it is going from 0 to positive. So the mean is higher because it is further away from the origin, and mode is smaller. So do not confuse the peak with the highest. This is just a distribution that they're talking about. So that means this value, there were more of this values. Another thing that researchers report about is the kurtosis. The kurtosis is, even though we may have a normal distribution, sometimes the distribution would be overly peaked, which is a leptokurtic, or it could be very flat, which is a plateaukurtic. And if it is neither flat or neither overly peaked, it is called mesokurtic. So these are the things for you to remember. Leptokurtic is peaked, plateaukurtic is flat. Flat means flat. Like lepto means leap somewhere. So that is where it comes with. So now we're going to switch gears a little bit because we've been looking at the representation, data representations. But one of the first we also need to know is what are the different ways the researchers represent the visual representations of what we are reading. So here is an example. This is not from your book, but you do have simple frequency and group frequency in your book. So when you look at the simple frequency, it basically says this is your age category, which is your nominal data. And in this age category, we have 18 years is 213. 19 years is 302 frequency. So if you calculate the percentage, we take this frequency divided by the total and multiply by 100 will give you the percentage. So, and then this is just rounded off percentage. So look at this percentage and then look at the cumulative percentage. What is this change happening? Why does it say cumulative here? That means when we are talking about 19 years, it includes 18 years. So when we are talking about 20 years, it includes 19 and 20. So your frequency is all of this added up, divided by this, and then you get your percentage. So that is the difference between percentage and cumulative percentages. So when I'm looking at a simple frequency graph, just these two columns, if I want to say something that is 20 and below age, so then I have to take 20 and all of them. But if I just say below 20, then it is just 18 and 19. So those are the things. Be careful about it. If you look at your table on page number 19, you have your number of days per week and number of students. So if I talk about number of days per week, that is 5, less than 5, it includes all of them, 4, 3, 2, 1, and 0. And so I have to add all of those frequencies, not the percentage. I have to add all of those frequencies to get, and then find out the percentage. So that is another thing to keep in mind. On page 20, it gives you an example of a group frequency, which is with class intervals, because you have men, women, and total. What is really important, here is an example of group frequency again, 60 up to 70. So they are with the class intervals. There is loss of information here because I don't know how many are 61 kgs or how many are 62 kgs, or what is it, that is it all that are 69 kgs, all 13 are 69 kgs. So when we have an intervals, class intervals like this, there is at group frequency like this, there is loss of information. To combat that, we actually have what is called a STEAM stem and leaf display, which helps in removing the loss of information. So I just moved it a little bit so that you guys can see it. So here is my stems, and this is my stem width. So this is basically, that means it is 90, 96. These are the two values shown here. This is 71, this is 76, 76, 77, 78 in this category. So in the interval from 70 to 80, I have 1, 2, 3, 4, 5 values, and I also know the individual values that is there. So there is no loss of information. It tells me the lowest and the highest value. So I know the lowest is 16 and the highest will be 96. It doesn't say the intervals, but it tells me the lowest and the highest. It tells me specific ages within the interval. So 43, 44, 47, 48, because the stem width is 10. It also tells me which one doesn't have any values, gaps inside the intervals. So stem and leaf stem plot is a really, stem and leaf display is a very good display. The last two things are the histograms and the bar graphs. The histograms and bar graphs are again very good way of representing information. If you look at it, these are both histograms. Do you think they're any different? No, they are the same information, but just their axis is changed. What is the difference between a histogram and a bar graph? If you look at a histogram, your horizontal axis is a quantitative quantity. It is numbers. But in a bar graph, it is actually qualitative. So it is apples, oranges, bananas. So that is one of the biggest difference between a bar graph and a histogram. But both of these are representing data, summarizing the data, providing you with the frequency. So this is your frequencies, and you can label them. Like over here, you'll see it is 5, 10, 15, 20. So I know that how many like apple is 35. I can use this information to actually make a table and do the statistics, find the mean, find the mode, find the mean, median, mode, and do a standard deviation. This is why I explained those things first before I did this. Here I could make, I have not labeled my y-axis, but this could be 10, it could be 20, and then accordingly I will know what is the frequency. Now when you look at the bar graph again, the x-axis is the one that has the number of people. So this was all about the chapter 2. There is more reading, practice, and fun with statistics at this website of readingstats.com. I would strongly recommend you, for at least for chapter 2, take the online interactive quiz, get immediate feedback to understand the concepts better. Do not hesitate to post any questions on the course question discussion board. I will be more than happy to answer your queries. Your quiz is based on this PowerPoint and also on some of those things that is given in your chapter 2. If there are any questions, please do not hesitate. I am here to support you guys be successful in this course during your summer semester. Happy to have you guys in class.